Okay, let's continue talking about differentiation. Today we're going to talk about related rates, which is actually a prior problem. Of implicit differentiation. So for this particular section, we'll learn how to find a related rate. Use related rates to solve real-world problems. Okay. So first one, let's take a look at how to find the related rates. The chain rule, right? It's what we use to find the derivative implicitly. Another important use of the chain rule is to find the rates of change of two or more related variables that are changing with respect to time t. So for example, when water is drained out of the conical tank, see the figure on the right. The volume V, the radius R, and the height h of the water level are all functions of time t. Knowing that these variables are related by the equation V equals to pi over 3 times R squared times h. This is the original equation. And this is the motion describing the process of a drain out of the conic tank. And you can differentiate implicitly with respect to t to obtain the related rate equations. Okay, so basically what you do is write an equation pi over 3 times R squared times h. Then basically we're going to differentiate everything with respect to time t. So dv over dt. And here we have to use the product rule. So this is our f, the g. So f equals to R squared. F prime is equals to 2R times dr over dt. And g is h, and g prime, which is 1 times dh over dt. Then we just apply the product rule. So f prime 2R times dr over dt times g, which is h, plus f times g prime, so it's R squared times dh over dt. Okay, then just simplify this, so end up with dv over dt equals to pi over 3 2rh times dr over dt plus R squared times h over dt. Okay. From this equation, you can see that the rates of change of V is related to the rates of change of both R and H. Okay, meaning this thing is related to two things, this and that. Suppose that x and y are both differentiable functions of a t and are related by the equation y equals to x squared plus 3. Find dy over dt when x equals to 1, given that dx over dt equals 2 when x equals 1. Okay, so first of all, we gotta differentiate this implicitly with respect to time t. So first of all, we do dy over dt. And this one, x squared, derivative of x squared is 2x. Just remember we have dx over dt. And derivative of constant becomes 0. Okay, so end up with dy over dt equal 2x times dx over dt Now looking for this, so since x equals to 1, dx over dt equals 2, just replace both with a given number. So you get 2 times 1 times 2, which is 4. Okay, that means change of y over time t is 4 units. Alright, so next let's take a look at problems solving with related rates. So first of all, there are several steps, guidelines for solving related rate problem. First step, identify all given quantities and quantities to be determined. Make a sketch and label the quantities. Second step, write an equation involving a variable whose rates of change either are given or are to be determined. Use the chain rule. Implicitly differentiate both sides of the equation with respect to time t. So this is the key thing, right? You differentiate everything with respect to time t. After completing step 3, substitute into the resulting equation all known values for the variables and then their rate of changes, then solve for the required rate of change. Okay, so far unknown basically. So let's take a look at the example. An inflating balloon is being pumped into a spherical balloon. See below, this is the motion at a rate of 4.5 cubic feet per minute. If you look at this, what is this called? Cubic feet, right? If you just look at the unit, cubic feet per minute, that should be change of volume over change of time, right? So it's 4.5 cubic feet per minute. So it's given that. Now find the rate of change of the radius when the radius is 2 feet. So radius equals 2 feet. Okay, those are the given information from the question. And this is the motion, just balloons getting bigger and bigger. And that will be the volume of the balloon and R be its radius. So EV equals to so the volume formula is 4 over 3 times pi r cubed. Alright, so first of all, we just gotta differentiate everything with respect to time t. So dv over dt on the left, 4 over 3 times pi, and differentiate r cubed becomes 3r squared times dr over dt. Now we know that dv over dt is given, which is 4.5 cubic feet per minute. And radius r is basically equals to, from previous slide, 2 feet. So now just got to replace dv over dt, given number, replace r with the given number, right? So we got 4.5 equals 4 over 3 pi times 3 times r squared, which is 2 squared, times dr over dt. Simplify the left hand side, we're going to end up with cancel that, 16 pi times dr over dt. Now dividing both sides of the equation by 16 pi, then you end up with cancel that, dr over dt equals 4.5 times 16 pi. And this is feet per minute. That's a unit for the change of radius over change of time. And this is a detailed solution, but you can definitely take a look at solution from the